Watch the complete playlist on the app Pions. Download the app now.
Question 1 says differentiate with respect to x the function sin x whole raised to cos inverse x. Okay, let me remind you once again, if there is a function in the power of another function, if there is a function in the power of another function, then we use the method of log. So let's take u equals sin x whole power cos inverse x. Next, let's take log on both the sides. So log of u equals log of sin x whole raised to cos inverse x. Let me repeat again. Log of a raised to b, that will be b log a. Now let's take this cos inverse x in front, cos inverse x in front, log of sin x. That is equals to log of u. Correct. Now what's the derivative of log of u? Derivative of log of u is 1 by u du by dx, and that will be equals to, what is the derivative of cos inverse x? Now here we will make use of multiplication rule. This is one term, log sin x, and cos inverse x is another term. So differentiation of d by dx of cos inverse x log sin x as it is plus cos inverse x as it is, differentiation of log sin x. Now du by dx will be equals to, take the u on the other side, derivative of cos inverse x minus 1 by root under 1 minus x square log of sin x plus cos inverse x, derivative of log sin x. Be very careful. First we will differentiate log. Log of something is 1 upon something, and derivative of sin x is cos x. Done. So let's substitute the value of u to get our final answer. So u, in place of u, let me write here in place of u, sin x whole raised to cos inverse x, derivative of that will be equals to u. What is u? Sin x whole raised to cos inverse x into minus log sin x whole divided by root under 1 minus x square plus cos inverse x and cos x upon sin x, that is cot x. Done. This is our answer to the first question. Let's move to question number 2. Question number 2 says differentiate with respect to x the function x raised to sin x. Let's do it again, because this is again based on function to the power function. So take u is equals to x raised to sin inverse x. Correct. So taking log both the sides, log of u equals to sin inverse x will come in front, and here you left with log x. Okay, which identity? The one which we used in the question number 1. Now next, log of u is what? 1 by u du by dx. Derivative, let's use multiplication rule. So multiplication rule, sin inverse x derivative is 1 by root under 1 minus x square. Log x will remain as it is, plus sin inverse x as it is, and derivative of log x 1 upon x. So I'm writing it here. Du by dx, that will be equals to u. Let's take u on the right hand side, which is x raised to sin inverse x, and multiplied with 1 upon root under 1 minus x square into log x plus sin inverse x upon whole divided by x. This is our question number 2. Great. Let's move to question number 3. Question number 3 says differentiate with respect to x the function, this one. Now as you can see, this whole thing is in division rule. Let me write division rule for you here. D by dx of anything in this format, u by v, that will be v du by dx minus u dv by dx whole divided by v square. Correct? So this will be our relation. Let's apply this relation over here. Our u is this whole thing, numerator, and v is the denominator. So let's apply it here and differentiate it. So this will be v, which is sine 3x in the denominator, sine 3x, okay, sine 3x, d by dx of e to the power x plus log x, okay, minus u is what? E to the power x plus log x, the numerator, and derivative of denominator d by dx of sine 3x whole divided by sine 3x whole square. Now this will give us sine 3x, derivative of this thing whole thing will be e to the power x plus 1 by x minus e to the power x plus log x, derivative of sine 3x cos 3x, okay, into 3. Derivative of sine 3x is cos 3x into 3 whole divided by sine square 3x. Done. This is our complete answer for question number 3. This was our third one in today's lecture. Let's move to question number 4. We have our fourth question. Question says differentiate with respect to x the function. So let's differentiate d by dx. The function here is x, log is there outside. So log of x plus root under 1 plus x square. Now derivative of log of something, pay attention, derivative of log of something, this is that something written in front of log of something whole divided by 1 upon something, something is this thing. So this is the differentiation of log. This we have differentiated log. Now differentiation of that something. So derivative of x is 1, derivative of root of 1 plus x square, 1 by 2 root under 1 minus plus x square. Derivative of root of 1 plus x square is 1 by 2 root of 1 plus x square. Done with the power, the root. Next is derivative of 1 plus x square, which is 2x. I hope this is clear. Let's simplify if it gets simplified. So 1 upon x plus root under 1 plus x square, and this will be root of 1 plus x square. I'm just cancelling this 2 with 2 and taking LCM or cross multiplication whole divided by 1 plus x square. Let me repeat again this step. I simply cancelled this 2 with 2 and I took this root of 1 plus x square on the left hand side multiplied with 1 and then simply common denominator. Now, if you look at the numerator of this bracket and the denominator of this second bracket, okay, they will cancel out straight away. So what you left with 1 by root under 1 plus x square. This is your final answer to question number 4. Done. Let's move to the fifth question. Fifth question here says if x is equals to 80 square and y equal to 280, find d square y by dx square. Very important question. Conceptually very important because majority 99% students go wrong here. Why and where they go wrong? Let's see. Okay, it seems very easy directly. Okay, but what is the common mistake that I will tell you at the end or maybe in between. So first of all, let me remind you, this is nothing but parametric form. X is a function of t, y is also a function of t. So if x is a function of t, dx by dt first we will find, and that will be equals to how much? Derivative of 80 square. So d by dt of 80 square. 80 square, a is constant taken out and derivative of t square 2t. This is our differentiation of x. Differentiation of y, dy by dt, and that is equals to 2a will come out and dt by dt, that is equals to 1. So 2a. Now let's find dy by dx. Let me remind you, dy by dx is nothing but dy by dt whole divided by dx by dt. dy by dt here is nothing but 2a, dx by dt is 2at. So dy by dx is 1 by t. Okay, great. Now what's the most common mistake students do? Let's talk about that. They directly differentiate this d square y by dx square, and they write it as, so derivative of dy by dx, d square y by dx square is nothing but d by dx of dy by dx, right? So if you differentiate what you got dy by dx, once again you will get the double derivative. Now that's fine, fine it is. So if you differentiate d by dx of 1 by t, okay, 1 by t, students, what common mistake they do is, listen very carefully, they don't write this d by dx, and straight away they do the differentiation of 1 by t, and they write it as minus 1 by t square. So from where you got this differentiation? If I take 1 by t as t to the power minus 1, then differentiation of t to the power minus 1 is minus 1 t to the power minus 2. Let me repeat, t to the power minus 1 is minus 1 t to the power minus 2. That should be the answer, right? And they write it like this and they think that this is correct. No. Be very careful, since you don't write in exam this step as well as this step. This is the most common mistake students do because of this step and this step. When you are double derivating this, when you are differentiating it twice, you have to differentiate it with respect to x. But if you look on the right hand side, there is a function which is in terms of t, and you are differentiating it with respect to x. So this automatically becomes an implicit function. So here when you are putting this, not only minus 1 by t square is the answer, the next part should be dt by dx. Let me repeat again. When you are differentiating 1 by t with respect to x, it is minus 1 by t square. That is the derivative of t to the power minus 1, the power. Then you have to differentiate this t also. That will give you dt by dx. Clear? Implicit functions, let me remind you, y, like if you differentiate sine y, so derivative of sine y is cos y into dy by dx. Why we write this dy by dx? Because this is not a function of, this is not x, this is a function of x, so dy by dx. Same question, if it, instead of sine y, if it was sine 1y, then what you will do? Then you will do cos 1 by y, that is differentiation of sine. Then derivative of 1 by y, minus 1 by y square. Done? No. Still dy by dx will also come here. Okay. So be very careful with this. When your function, what you are differentiating is not of x. So derivative of 1 by t minus 1 by t square dt by dx. Sir, how to get dt by dx? Let's look at the first equation over here. Okay. So our dx, okay, from here, let me write here, and dx by dt, that was nothing but 280. So this implies dt by dx, that will be equals to 1 upon 280. Be very careful, reciprocate dx by dt. So let's substitute here. So our double derivative d square y by dx square, that will be minus 1 by t square, and dt by dx is 1 upon 280. So our final answer for this is minus 1 upon 2a t cube. That is our double derivative of this parametric form. Be very careful with this in parametric form whenever they ask double derivative, because on the first derivative you will get always a function which is not dependent on x, like theta, if it is sine theta, t, or some other variable, always. So this is the place where 99% people go wrong here. In double derivative, single derivative, not an issue. So this is our answer for fifth one. Okay, so question number 6 over here. If y is equals to x plus 10x, then prove that this is equal to this. Okay, so here you have to use your brain, simplify and get it in this particular format. So if y is equals to this, let's first find what you need here, double derivative, right? So there is no role of single derivative over here in the whole equation. So first, to reach up to second derivative, first you have to differentiate it once. Let's find dy by dx here. So dy by dx will be equals to derivative of x 1, derivative of 10x sec square x. I hope this is clear. Okay, so if you look here, okay, there is double derivative, but there is no sec. So we will talk about what to do with this sec square x later on. Let's first simplify and find the double derivative. D square y by dx square equals to derivative of 1 with respect to x 0, sec square x, 2 will come in front, sec to the power 2 minus 1, done with the power, differentiation of sec x tan x. Let me remind you once again, power will come in front and power decreases by 1, that will be 2 sec x, and derivative of sec x tan x. Great. So double derivative d square y by dx square, that is equals to 2 sec square x into tan x. Clear it is? Okay. So this is our the thing. Let's simplify it further and see if we can manage to get it into this thing, right? So what I'll do, I'll simply convert that sec square x, okay, into cos. So 2 upon 2 tan x, let's keep it like this, sec square x cos square x. Let's take this cos square on the left hand side. It will be cos square x d square y by dx square equal to 2 tan x. I hope this is clear. I took this cos square x on the left hand side and multiplied with this, I got 2 tan x. Now let's recall our main equation. Our main equation is y equal to x plus tan x. If I take this x on the left hand side, it will be y minus x equals to tan x. And if I multiply the whole equation with 2, why you are doing so? So that I can substitute here. I need 2 tan x. So 2y minus 2x is equals to 2 tan x. Let's substitute here. So over this equation will take the form cos square x d square y by dx square, and that is equals to 2 tan x, that is equals to 2y minus 2x. Great. Let's take here both the terms on the left hand side. So it will be cos square x d square y by dx square minus 2y and plus 2x equals to 0. Is it matching to the equation we want? Yes. So this is our answer to question number 6. Let's move to question number 7. Question 7 says differentiate sine x square with respect to x square. Okay. So this question is another way. The language is different. Okay. But this is actually parametric form only. Okay. How? We will see within a minute. So sometimes just to confuse you, okay, what they will do, they'll ask you like this: differentiate sine x square with respect to x square. Then you will sit and think that maybe x square, this is a misprint and it should be x. Okay. So be very careful with this. This is another way of saying which one? Parametric form. So to find that, let's assume that u equals to sine x square and v equal to x square. So basically they are finding what? They are asking our du by dx, du by dv. Yes, differentiation of sine x square with respect to x square. U is sine x square and v is x square. So you can say d by dx x square of sine x square, right? In a simple sense. This is the language. So always remember, if they are asking you a question like this, differentiate this particular thing with respect to something other than x square. Sorry, x. Like sine x also they can ask, tan theta also, anything they can ask over here. Then this is indirect way approach to parametric form. So let's first find du by dx. Du by dx will be, what is the derivative of sine x square? Cos x square. Sine theta is cos theta and derivative of x square 2x. What is the derivative of x square? dv by dx, that will be equal to 2x, as simple as that. So du by dx is that, dv by dx is this. What you have to find? Du by dv. How do we find du by dv? Du by dv will be equals to du by dx whole divided by dv by dx. Correct? And when you divide both, it will be 2x into cos x square whole divided by 2x. So our final result for this is cos x square. This is the differentiation of sine x square with respect to x square. Let's move to our next question. So our next question, question number 8, it says y equal to tan x plus sec x. then prove that double derivative is this. Now you have to be little careful with this. So y is this. Let's find a dy by dx. To get the double derivative, first you have to find the single derivative. So derivative of y with respect to x will be d by dx of tan x plus sec x. Now derivative of tan x is sec square x and derivative of sec x is sec x tan x. This is our dy by dx. Correct? Okay. Next is, let's differentiate it once again. So let's differentiate d square y by dx square. What is d square y by dx square? Derivative of what you got for dy by dx. And what you got for dy by dx? Sec square x plus sec x tan x. So derivative of sec square x, pay attention, 2 will come in front, sec to the power 1, done with the power. Now differentiation of sec theta tan theta, done with the sec. Let's move to the next one. Sir, what to do here? Be very careful, they are both multiplied together. So you will use multiplication rule here. Some students, they do what? They write here sec theta tan theta and then they differentiate tan theta also all together. If two things are multiplied, you don't have to differentiate both of them together. You have to do one by one. That's a multiplication rule. So derivative of sec theta is sec theta tan theta, and derivative of tan theta is, sorry, tan as it is, and plus derivative of tan theta is sec square theta into sec theta. Done. This is our complete differentiation of this d square y, but it doesn't look like that. So which means you can see on the right hand side, okay, a direct guess must be, look at the right hand side, there is no sec or tan. So we have to convert them into sine and cos to make it simplified. So 2 times sec 1 by cos, be very careful, sec 1 by cos, tan sine x by cos x, plus sec 1 by cos, tan sine x by cos x, tan sine x by cos x, plus 1 by cos square x into sec x 1 by cos x. I hope this step is clear. Now if you look at all these expressions, look at the first expression, second expression, and the third expression. All of them have cos cube x in the denominator. So nothing to worry about since all of them have a common denominator cos cube x. First term 2 sin x, second term sine square x, and the third term is plus 1. Okay, great. Let me write it here. Pay attention. The numerator is 1 plus 2 sin x plus sine square x. That is nothing but 1 plus sin x whole square, right? So 1 plus sin x whole square, that is a plus b whole square, a square plus b square plus 2ab, right? Whole divided by cos cube x, that can be written as cos x into cos square x, right? Now cos square x is nothing but 1 plus sin x whole square cos x into 1 minus cos 1 minus sin square x. Cos square x is 1 minus sin square, right? Sin square x. Now 1 minus sin square x, that can be further written here as 1 plus sin x whole square upon cos x into 1 plus sin x into 1 minus sin x. Correct? Let's cancel this with this. Okay. So what we left with? So let me remove this previous part so that I'll get little space over here. So let me remove this whole thing. Let's remove this whole thing and let's solve the further part over here, remaining part. Okay. So this, I hope all of you understood the previous part. Okay. So when you solve this part, it will be 1 plus sin x whole divided by cos x into 1 minus sin x. Now what? Now rationalize it once again. 1 minus sin x upon 1 minus sin x. And when you do that, in the numerator it will be 1 minus sin square x whole divided by cos x into 1 minus sin x whole square. Now 1 minus sin square x is nothing but cos square x whole divided by cos x into 1 minus sin square x, sin x whole square. So when cos x and cos square x cancels, your final result gives you d square y by dx square will be equals to cos x upon 1 minus sin x whole square. This is our complete answer. Let's move to question number 9. Question number 9 says y equal to this, then find dy by dx. Again, that it's a mixture of two questions. Okay, now this is important. Why it is important? Because this is a mixture of two things and again a conceptual thing. What is the biggest mistake students do in this question? They take log on both the sides. Okay, you don't have to take log. How they do? Let me explain you, and that is a wrong approach. Let me explain you what is wrong in that. They take this log, then they take this log x raised to sin x minus cos x, and then they take it plus log x square minus 1 upon x square plus 1. This is completely wrong. Why? Log of a plus b is not log of a plus log of b. When you are taking log both the sides, it is log of this whole thing, right? And log of a plus b is not log a plus log b. Log of a into b is log a plus log b. So this is completely wrong. Then, sir, how to proceed? Let's see. So first of all, let me take this thing as u and let me take the other thing as it is. Correct? I'm just keeping it as it is because it's easy division rule it is. Now dy by dx will be equal to du by dx plus d by dx of x square minus 1 upon x square plus 1. Okay, we will have to solve this. Let's figure out what is du by dx. So u here I have taken as x raised to sin x. Here I don't have any choice. I have to take log. Why I have to take log? Because it is function in the power of function. Taking log both the sides, it will be log of u equals to sin x minus cos x log x. Power will come in front. Let's differentiate it. 1 by u du by dx will be equals to differentiation of sin x minus cos x. Cos x and cos x derivative minus minus plus sin x. Let me repeat again. Differentiation of cos x is minus sin x. That's why it became plus log x as it is. Plus sin x minus cos x and derivative of log x 1 upon x. Du by dx will be equals to u, which is x raised to sin x minus cos x whole into this whole bracket cos x plus sin x into log x plus sin x minus cos x whole divided by x. Let's substitute here and find our dy by dx because they are asking in the question dy by dx. So dy by dx, pay attention, it will be equal to du by dx. That is nothing but, let me keep a huge bracket, x to the power sin x minus cos x cos x plus sin x log x plus sin x minus cos x whole divided by x. This is du by dx. And then plus the differentiation of this part. And this is what? Division rule. So let's do it directly because it's very simple now. By now you should all know division rule. So division rule says denominator as it is, differentiation of numerator. So differentiation of x square minus 1, 2x minus numerator as it is, differentiation of denominator 2x whole divided by the denominator square, x square plus 1 whole square. So this is our complete answer to this particular problem. Done. Let's move to question number 10. Question 10 is our parametric form. Okay. And this is again this type of question mostly they ask in competitive exams, so that just to check, because they have one particular value as their answer. So x is this. So x is 3 sine t minus sine 3t. Y is this. Find the double derivative. So be very careful with the double derivative. I have told you in this lecture, because after single derivative it will give you a function of t. So x dx by dt, let's do it directly. That will be 3 cos t, and sine is cos 3t into 3. Correct? What will be your dy by dt? Dy by dt will be derivative of cos minus 3 sine t, and cos 3t minus minus plus. Cos derivative is minus sine, so that will give you plus sine 3t into 3. Now, how do you find dy by dx? Sir, dy by dx is nothing but dy by dt whole divided by dx by dt. Now, dy by dt is what? Let's take minus 3 common. It will be sine t minus sine 3t. Correct? Sir, why you took negative 3? I can cancel out from the denominator. Okay. And then I'll put the negative sign, doesn't make any difference. Okay. So 3 taking common in the denominator, cos t minus cos 3t. I hope this is clear. Let's cancel out and multiply the negative sign back. Okay. So this will give you, I'm just writing sine 3t before and minus sine t. Okay. And just to avoid any confusion with the negative sign. Let me repeat again. This negative sign with minus sine t here and minus minus plus sine 3t. So I wrote that first to avoid that negativities. Okay. This is our dy by dx. Is it our double derivative? No, it's our single derivative. So, sir, how do you find double derivative? Now, be very, very careful, because some or majority people go wrong here. How do you find double derivative? Pay attention here, focus here for the next few minutes. Double derivative will be division rule we will apply. So, denominator as it is, cos t minus cos 3t as it is, keeping in bracket everything. Derivative of the numerator. Be very careful. Derivative of sine 3t, cos 3t into derivative of 3t, 3 into dt by dx, minus, be careful with this dt by dx, derivative of sine t, cos t into dt by dx, minus numerator as it is, sine 3t minus sine t as it is, differentiation of denominator, cos minus sine t dt by dx, minus minus plus sine 3t into 3 dt by dx, whole divided by denominator square, which is cos t minus cos 3t whole square. You can see the size of the question. Okay. Let me just recheck it to avoid any mistakes. Differentiation of the numerator, sine 3t is cos 3t into 3 into dt by dx, sine t is cos t into dt by dx. Differentiation of denominator, cos t is minus sine t dt by dx, and minus minus plus sine 3t into 3 into dt by dx. Great. Now, the most biggest problem students do, okay, as a beginner. What they will do, sir, in the beginning, first or second question, you explained us how to find dt by dx by reciprocating dx by dt, right? So what students do, pay attention, and which better you avoid it, though you can do that, doesn't make any difference. Dt by dx will be 1 upon 3 cos t minus 3 cos 3t, right? Majority of people do that. What they'll do is they'll put this value over here, dt by dx, and make it more complicated. You can do that. You can do that. Better is, even after replacing it here, we don't have to do any operation, right? After putting it here, you don't have to do any operation. You have to simply put t equal to pi by 3. So why don't we directly put here and put these values here to make it more simple, right? Again, I am repeating. I am putting this t equal to pi by 3 here to get the value of dt by dx. And I'll put that value over here because I don't have to differentiate it again. If you have to differentiate it again, then you have to be very careful. Then you will not initially put. Okay, I'll explain you that again. Let me first put it. So 1 upon 3 times cos pi by 3. Pi by 3 is 60 degree minus 3 times cos pi by 3 into pi cos pi. Right? When you'll put here t as pi by 3, 3 cancels, you're left with pi. So this value will be 1 upon cos pi by 3 half minus minus plus 3. Why? Cos pi is minus 1. So 3 by 2 plus 3. That will be 2 will go in the numerator and 3 plus 6. So this will be 2 by 9. Let's reconfirm this value. So cos pi by 3 is 1 by 2. Okay. And cos pi is minus 1. Correct. So 3 by 2. So 2 3 is a 6 and 3, yeah, 9, 2 by 9. Okay. Sir, what if I initially put here 2 by 9 and then differentiate here and here, then it will be a big problem because differentiation of constant will be straight away 0, right? So be very careful. Put this value, whatever value they have given, when you have to substitute here. Let's solve here directly. So you can see all over there, few terms are repeated. Which terms are repeated? I am doing it here. I am writing here. So let's write it here as cos t. What is cos of pi by 3? Half. What is cos of 3t? Which is pi. Cos pi is minus 1. Next is sin t. So sin pi by 3. Sin pi by 3 is sin 60 root 3 by 2. And sin 3t, which is sin pi. Sin pi is 0. Okay. So these values you will get. So let's put directly cos t, which is half, cos 3t minus 1. So plus 1. Cos 3t minus 1 into 3 into dt by dx 2 by 9. We just now found. I am putting here now minus cos t half dt by dx 2 by 9 minus sin 3t. Sin 3t, what we got? Sin pi. Sin pi is 0. Sin t. Sin t is how much? Sin pi by 3. Sin pi by 3 is root 3 by 2. Minus, be very careful with the signs. Minus sin t. Sin t is how much? Root 3 by 2. dt by dx 2 by 9. Plus sin 3t is 0. Into anything is 0. Whole divided by cos t. Cos t is half. Cos 3t is minus 1 whole square. Let me remove this place now because we have already used these values. Okay. And then let's use this space to simplify our final result. So I hope how we got dt by dx is clear. Okay. So let me remove this 2 by 9 and all these, and let's solve the remaining part of the given problem. Okay. So half plus 1, 3 by 2 into 2 3 is a 6 minus 6 by 9 minus 1 by 9 minus minus 3 by 2, and that is root 3 into 2 cancels minus root 3 by 9. Okay. Whole divided by 3 by 2 whole square. Correct. Minus 6 and minus 1 minus 7 by 9. So 3 by 2 into minus 7 by 9 minus this minus plus, and a 1 minus is sitting outside. So 3 by 18. Correct. Whole divided by 3 3 is a 9 by 4. This will give you minus 21. One second. Minus 21 upon 18 minus 3 upon 18 whole divided by 9 by 4. Let's simplify it further. 21 minus 3. 24 minus 24 by 18 divided by, so division I am converting with multiplication, it will become 4 by 9. 4 will go on the top and 9 will be down. Let's simplify. If it gets 6 4s are 6 3s are 4 4s are 16 upon 27. Negative 16 upon 27 is our final answer for this complete problem.
Watch the complete playlist on the app Pions. Download the app now.